Well. Look who's back. I knew you'd be back because I knew you wanted to learn how to graph some rational functions with some pretty quick and easy transformations. I knew this about you. So, a rational function, uh, it forms a hyperbola, which is like two different splits of the graph, sometimes even three. It's pretty wild. But there are these asymptotes, which we've kind of touched on before. An asymptote is a line that your graph will approach, but it'll never quite touch that line. So there will be horizontal asymptotes and there will also be vertical asymptotes. Hey, watch your language when you're saying that, okay? So the rational function f of x, or y, equals 1 over x. That's like your starting uh, formula here. Here's what the graph of it looks like. If you look, there's dots at 1, 1 over here. Maybe if I can write. Hello, there we go. So you have dots at 1, 1 and negative 1, negative 1. And then it forms these curves. If you zoomed out even further, it would just look like, I guess that looks the same. So if you zoomed out, it'll look exactly the same. But it'll approach these asymptotes, which the asymptotes start as the x and y axis, but they do move around with some transformations. It'll approach that line forever, infinitely closer, but it'll never touch that line. So there's two different chunks. As soon as you hit 0, then it turns up into this upper right quadrant. It's wild. You're going to love it. But take a look. Man, I'm having a hard time with the words. It's late in the day. All right. As far as the transformations, in the denominator, you're going to see something with the x usually, and that will give you your right and left transformation. It'll also give you that vertical asymptote, because what can you not divide by? 0. So just like when we were solving rational equations, you're thinking about those undefined values or those excluded values. Those will be where your asymptotes form. So again, in the denominator with the x would be a right and left shift. That'll be your asymptote, and eventually. And then outside of it, outside of the fraction, if you have a plus or a minus there, that's your vertical shift. So that would move the vertical asymptote from 0. If it said plus 3, it would shift it up 3. If it said minus 4, down 4. And then in the numerator, if that number is larger than 1, it turns into a stretch. And if it's between 0 and 1, it makes it a compression. Also, if you have a negative lead coefficient in either the numerator or the denominator, it's going to reflect those that graph. So let's just start with some basic transformations. Keep it basic. So if we were to draw like the general 1 over x graph, again, it starts at 1, 1, and negative 1, negative 1. And it'll approach that y-axis, but it would never touch it. Same thing here. That kind of looks like a right angle, but it's supposed to be a curve. If you were to zoom in and I was less terrible at drawing graphs, you would be able to see that. So now you'll see the only difference between 1 over x and this equation is this says 1 over x minus 3. So it is a right or left shift of 3. If it is minus, you're actually going to shift it to the right that many units. So there's going to be an asymptote at 3 now. So we're just going to take basically this, copy and paste it 3 to the right. So let's see. From there, if we went up 1 over 1, woo! Whoa! There was no vertical transformation, so it's going to keep approaching that x-axis. But again, never quite touching. So again, all we did was shift the graph 3 units to the right. Translated right 3 units. Let's think about the transformation here. It's got the minus 2, but that's not paired in with the fraction. So that's your vertical transformation. So this would be translated down 2 units. So if our initial graph, your 1, 1, your negative 1, negative 1, and you're going to get so used to that shape. But now everything is dropping down to units. So just here. So all we did was take our our horizontal asymptote from 0, or the x-axis, and we dropped it down to. So here would be like the new horizontal axis, or sorry, asymptote. Gets a little wild, and oftentimes we're going to have more than one transformation that we're going to have to do here. For the rational function of this form, we already talked about this. There is a vertical asymptote at the line x equals h. So again, the vertical asymptote, the up and down line, is determined by if there's something paired with the x in the denominator, that's a right or left shift. The horizontal asymptote starts at 0, and it would only change if you have this positive k in the back that would shift the graph up and down. As far as domain and range, remember that your domain is all your x values. Now it starts off basically unlimited, could be all real numbers, except what would x have to be in the denominator for it to equal 0? So if it said -7, you would say, well, there's an asymptote at 7. So the way you write that is x, maybe, there we go, x such that x is not equal to h. So you'll have something like x minus 3. So you would say, oh, the domain is x such that x is not equal to positive 3. Because positive 3 would give it a denominator of 0, which is undefined. You cannot have 0 in the denominator. So let's try this out. Identify the asymptotes, domain, and range of the function g of x equals 1 over x plus 2 plus 4. So the vertical asymptote, vertical would go this way. So it's determined by how far right or left you shifted it. And it says plus 2, which means we would shift left 2. So our vertical asymptote will be at x equals -2. Now, what does that mean as far as the domain? Well, that means that x can be anything. X is all real numbers except for -2, because that would give us a denominator of 0. So you say x such that x is not equal to -2. So again, the domain and the vertical asymptote are both gotten from that denominator, the x plus 2. The horizontal asymptote, the flat line that starts at 0, that defaults at 0, and then it gets shifted up and down if you have something at the back. So this says plus 4. So that would be shifted up 4. And a shift up 4 would be the equation y equals +4. That would give you a flat line at 4. So the range, again, all real numbers except for that 4. So y such that y is not equal to 4. So where I can see it getting a little confusing is like, if it says plus with the vertical transformation, it's positive. If it says minus with the vertical transformation, it's negative. It's the opposite with the horizontal translation. So the right and left shift, if it says +2, that means you're going to have an asymptote at -2. Because the initial formula has subtraction built into it. So you got to be careful on that. But you'll do it so many times that you'll get used to it. All right, sure. There are certain holes or breaks in some of these graphs. And again, this is going to be like where you can't divide by 0. So a discontinuous function is a function whose graph has one or more gaps or breaks. So if this was zoomed in a little bit, you'd see like an open point on this graph, and that is considered a hole. If you have an asymptote, that breaks up the graph a little bit. You can also have a jump. We're not really going to deal with jumps until we get to piecewise functions. And then a continuous one over here has no breaks or holes in it, which is like the standard stuff we've been doing. We haven't really had the breaks or holes in it yet. Consider the function f of x equals x minus 3 times x plus 2 over x plus 1 and its relationship to the graph. What do you notice? Well, let's look at some of our graphs here, or some of our points. Where it crosses the x-axis, it crosses at -2 and +3. Looking at the equation, you see maybe where they could have got -2 and +3? With the numerator, it says x minus 3 and x plus 2. So it's kind of like we're solving by factoring, right? If it says x minus 3, then it would be +3. If it says x plus 2, then it would be -2. So you get your zeros where it crosses the x-axis from the numerator, where you have x's. The denominator will give you that asymptote. If you look, it says x plus 1. The asymptote on this one is at -1. So you get your zeros from the numerator, where it crosses the x-axis, and you get your asymptote from the denominator. You get that vertical asymptote. So let's go ahead. I think our last thing we have to do is actually graph one of these bad boys. Woo! This is it. This is it. Oh my goodness. Identify the zeros and the vertical asymptotes of this. The graph. X squared minus 2x minus 3. You gotta factor it. So what factors of 3 are 2 apart? It would be 3 and 1. So to make them add up to -2, it'd have to be x minus 3 times x plus 1 over the x minus 2. Okay. Now let's get the zeros, which again are where it crosses the x-axis. If it says x minus 3, that means we're going to have a 0 at 3, 0, which is over 3. And x plus 1 would be -1, so -0. So here's going to be the two places where our graph crosses the x-axis. The denominator, the x minus 2, that tells us the vertical asymptote. So we're going to have a vertical asymptote at +2. VA at x equals 2. So if we kind of give ourselves a dashed line there. So we're looking for like pretty general graphs here. We don't need it super specific. But here's the basic idea. As you go from left to right, unless there's a reflection, you're going to go up and towards that asymptote. So from this dot, it's going to be going up infinitely closer. And then as we go, kind of trace it back to the left, it'll just curve back that way. And then once we hit here, it kind of does the opposite. So this is it was going towards the asymptote. Now as we go up here, it'll go away from the asymptote. And it'll get closer kind of as we get to the left of that. It'll get infinitely closer to that asymptote, but it'll never actually touch that line. Whew. Let's do a couple from the homework. That's where we're actually graphing. All right, let's try out these last two. Yep. Let's do maybe one of these. Let's do 12. We're going to factor it first. I'm just going to scooch it over so we can see the graph. In the numerator, they have an x in common. Come on, there we go. So we factor to x times x minus 5. The denominator is x minus 2. So the zeros, again, come from the numerator. And each spot where you see an x in the numerator. So this x on the outside could equal 0. So we're going to have a 0 at 0, 0. Right, this is giving us our x coordinate of our zeros. The y's, if they're a 0, are always going to be at 0. And then if it says x minus 5, then it's also going to have a 0 at 5, 0. So we have 0, 0, and 1, 2, 3, 4, 5, 0. These are the two places where it's going to cross the x-axis. The asymptote, the vertical asymptote, comes from this x minus 2. So we're going to have a vertical asymptote at x equals +2. All our x's are positive, so again, as we go from left to the right, it's going to increase. So from this 0, 0, as it approaches this asymptote, it's going to get larger. As it goes to the left, it's just going to get further and further away. And then it kind of reverses. So find this other zero, we'll go towards the asymptote, to the left, away from the asymptote as we go to the right. Dare we do number 11? We dare. All right, we got to factor the numerator. Factors of 12 that are 1 apart would be 4 and 3. So this would factor to x minus 4 times x plus 3 over x. As far as the zeros go, let's see. Zeros, look at the numerator. It says x minus 4, so we're at 4, 0. And it says x plus 3, so negative 3, 0. So 1, 2, 3, 4. Negative 1, negative 2, negative 3. And our vertical asymptote, there's no right or left shift here. So it's just going to be at 0, which is the y-axis. So from left to right, as it gets closer, it's going to go up vertically towards that asymptote. And as it goes to the left, it's going to pull further away. Once we hit that asymptote, it kind of goes in reverse. If I go to the left of its 0, it's going to go down towards that asymptote, and then it'll pull away from it over there. The graphs do the same thing a lot, so you'll get used to the patterns of it. If there was a negative in front, which I think we'll get more into tomorrow, then as it went from left to right, it would go from that 0 down towards the asymptote. That's just if you have a negative lead coefficient. So we'll get that tomorrow more.